If you're new to coding or data science, you've probably heard Git and GitHub tossed around in the exact same breath. It's easy to assume they're identical tools. Because of that confusion, many beginners skip learning the underlying mechanics and jump straight into downloading a visual interface, like GitHub Desktop, to handle everything. The problem is you end up learning which buttons to click on a specific screen, rather than how version control actually works. Eventually, you will hit a complex code conflict. If you've only memorized the interface, you won't have the mechanical knowledge to untangle the mess. Developing a clear mental model of how these tools interact is what allows you to stop following tutorials by rote and start troubleshooting your own workflow errors with confidence. Let's separate the two. Git is a distributed version control system. It runs completely offline, directly on your local machine. Think of it as a detailed personal time machine. Every time you save a new version of your code, Git takes a snapshot, letting you track exactly what changed and rewind if something breaks. GitHub, on the other hand, is a cloud-based hosting platform built on top of Git's architecture. Git is the engine managing the mechanical work of version control. GitHub is the garage where teams gather to work together. Ownership differs too. Git is open source, maintained by the Linux Foundation. GitHub is a proprietary service owned by Microsoft. Git is the underlying system tracking your changes locally, while GitHub is the centralized platform to host and share those changes with the world. Let's look at how Git functions on its own. Your daily workflow involves writing code, branching off to try new ideas, and committing those changes to your local history. This timeline shows how branching creates an isolated sandbox. You experiment safely. If it fails, delete the branch. If it succeeds, merge it back. But this power has a trade-off. You must navigate the command line interface, memorizing raw text commands without a safety net. And because this entire ecosystem lives solely on your personal hardware, there is zero off-site backup. Git gives you absolute control and privacy for your solo work. But if you spill coffee on your laptop and fry the hard drive, your entire project and its version history are gone. This illustrates the cloud layer. Once ready, you push your local history to GitHub servers, creating a centralized copy. Teammates pull your code to their machines. Before changes are added, they pass a gate check called a pull request, where the team reviews the code. GitHub also adds automation tools, like GitHub Actions. This allows you to set up continuous integration and deployment pipelines that automatically test your project for bugs every time someone updates the code. The catch is that utilizing these tools requires a constant internet connection, entails trusting your code to third-party servers, and requires significant upfront time to configure those testing pipelines. Pushing your work to GitHub turns a solitary offline experiment into an automated, distributed team operation. When you adopt this ecosystem, you are operating within a corporate environment. Trusting your code to GitHub means trusting Microsoft's enterprise infrastructure. This corporate backing is the reason GitHub is now rolling out AI-powered code generation through GitHub Copilot. Copilot can increase your development speed, but it also increases the likelihood of silently injecting poorly understood AI-generated bugs into your codebase. As GitHub moves further into AI assistance, possessing a deep mechanical understanding of your local Git commands becomes vital, so you can identify and roll back those automated mistakes. So, how should you actually set up your workflow? If you're a data science student or a beginner just learning the ropes, keep it simple. Commit to learning the core command line Git fundamentals offline first. Do not touch GitHub's visual interface until you understand what the text commands are actually doing. If you're an intermediate developer building out your personal portfolio, your needs shift. This scorecard breaks down the ideal solo setup. You should use local Git for your daily offline work, but push code to GitHub strictly to act as a remote backup and public portfolio for recruiters, skipping team features like pull requests or automated testing. Be extremely meticulous when you do this. As a solo developer, it is easy to accidentally push private API keys and passwords into a public GitHub repository if you aren't paying attention. For the individual, Git provides the necessary daily safety net, while GitHub secures your hardware insurance and career visibility.
Finally, if you're a professional working on a distributed enterprise team, the rules change again. Notice how this scorecard updates for the enterprise setup. teams must mandate a full hybrid workflow, utilizing pull requests and automated actions to ensure nobody's bad code can break the main project. The trade-off here is bureaucratic overhead. What might be a simple one-line code fix on your local machine turns into a formal multi-step review process before it's approved. Teams prioritizing self-hosted infrastructure often substitute GitHub for competitors like GitLab or Bitbucket, but they still keep Git running as the core engine underneath. Git is the foundational tool you learn to save yourself. GitHub's the platform you use to work with everyone else.